Hello again, register audience. We are live with you today, and we got something that's it's really timely, it's really important, and this could really get you out of a hole that you've been in for a while now. We're talking about ditching your data warehouse. How on earth can you ditch your data warehouse? Well, if your Lakehouse performance improves. Easier said than done, although we're going to do it today. Well, I say we, it's not we, it's Sida. Hello, Sida. How are you?
Hey, how are you doing? Hello, Tim. Thank you for having me. I'm doing fantastic.
Good. And tell me, CelerData. We haven't spoken to CelerData before, I don't think. Tell me
hmm
about CelerData. Tell me what you do there.
Okay, so CelerData is a data company. It's a database company. So we make query engine that runs at incredible performance on data lakehouse architectures, right? Against open table formats such as Apache Iceberg, Apache Hudi, Delta Lake, and Hive, right? So performance is mainly what we do, and we aim to use performance not only to shrink your AWS cost, but also to um, have you have easier data governance and also simplify your data pipeline and also make everything more cost effective.
Excellent. Tell me what you do at CelerData.
I am a product manager at StarRocks. So I design the product, I talk to users, and I interview users and tell me how much my product sucks, and I go back and I fix it. That's basically what I do.
We are live, so I don't know what sort of questions or comments we're going to get in today. Yeah. So if you want to tell Cedar that this product sucks, then of course you can do that.
Yeah.
However, if you
Yep.
do have any questions about what he's talking about today, then please do let us know. It comes into me. I read it out to him. He gives you an answer. And I talk to Cedar about this stuff. Believe me, there is nothing about this, what we're talking about today, that he does not know. There we are. Bigged you up on that one, Cedar. Let's see what happens. Okay, so this is what we're going to be doing in the next half hour, 40 minutes. We're going to be talking about the headaches you've got if you are trying to do queries on your data lakehouse. A better solution is possible. We're going to be talking about what it is, and we're going to show you a demo of it as well, so you can see exactly how it works. First of all, though, we better define our terms, Cedar. A data lakehouse, what is it?
Okay, so first let's get started with, what is a data lake house, right? We all know what is a data lake, right? A data lake is a place that you can just dump all of your data in there, right? But table format vendors such as Delta Lake, Apache Iceberg, and Apache Hudi, they've been adding data warehouse-like features to data lakes. They're adding features such as transactions, schema evolution, and compaction, right, to data lakes, to open and standardized storage. So basically what we're doing here today is that we're kind of reinventing data warehouses on open standardized storage, open standardized file formats such as Parquet files, ORC files, and open table formats such as Delta Lake, Apache Iceberg, and Apache Hudi, right? So why we're doing that? The reason is now we have a chance to unify all of our workloads on a single source of truth data, right? As opposed to, let's say you're using a proprietary data warehouse, the number of workloads that you can run on that, on the data that's enforced by the proprietary data warehouse in the proprietary format, right? It's limited by the data warehouse itself, right? It's probably, a connector here and there, you can do, but it's not going to be enough for you to run all of your workloads to satisfy all of your business needs, right? But storing everything in, let's say, Parquet files, you can run all of the workloads, all of the possible workloads on that one copy of data. So the benefit of doing just that is enormous, right? So first you
Mhm.
get easier data governance. There's only one copy of the data you need to worry about. And also simplifies your architecture because there is only one storage you need to worry about, and managing storage is expensive, right? And also you gain the flexibility of choosing whatever compute engine or application you want to run on that piece of data freely, right? You can plug in and unplug different kind of application without actually, moving your data or even your metadata at all, right? And overall, this is extremely cost effective. So Data Lake is great, right? Apache Iceberg, Apache Hudi, Delta Lake are great. So once people are using it, they must be like doing exactly this, right? One copy of data. But the problem is
I was going to
not.
say, it sounds too good to be
Yes.
true. Yeah.
Yes. Yes. It is or it's not.
Yeah.
So not yet. Users are still copying their data out of the data lakehouse for query acceleration because the query engine they're using for their data lakehouse is not fast enough.
Mhm.
Existing data lake query engines are either not optimized for high concurrency, low latency workloads. They're more optimized for batch than ones for hours, or they're still on older technologies and not really able to take advantage of all of the crazy optimizations we can do to a query engine now, today in 2024, right? So not being able to handle the demanding analytics workloads, like data warehouse like workloads. So the user basically has two choices. So first, the user they can over-engineer or overspend on existing query engines to barely get passable performance, right? This okay, but it's not sustainable. It's very expensive and it's not
Mhm.
future-proof. So what we see on the field is that as a workaround, users are often forced to move their workload and their data to a high-performance data warehouse, proprietary data warehouse, purely for query acceleration reasons, right? And this definitely addresses the performance problem, but introduce a whole new set of challenges, right, that comes with it.
This
So
this
first
sounds
you
like
have,
this sounds extraordinarily hard to do day to day and to
yes,
sustain.
yes, exactly. And now unwrap like what are the hidden costs, people are not really paying attention to, right? Because they're used to it. So first you have to consider the cost of actually maintaining an infrastructure level software like a data warehouse, right?
Mhm.
Stateful, it uses a lot of compute, use a lot of hardware resource. Anything that does that is error prone, right? It's expensive to maintain. And second, you have to consider the cost of the actual data ingestion pipeline from your data lakehouse to your data warehouse, or the other way around, depending on which, where the data hits first. So the data ingestion is basically writing your data from one format to another, doing that for terabytes, hundreds of terabytes, or some of our users, petabytes of data.
Mhm.
It's extremely expensive on the hardware and it's extremely error prone. And also you have to maintain data ingestion pipeline for each one of your table and consider some of our users has like tens of thousands of tables and that's not something that they actually want to do, but they're doing because they're used to it. They were doing because they were used to it. And you also have to consider the challenge of actually matching a schema, between the data warehouse and your data lakehouse and designing, indexes in your data warehouse, right? Matching data type, matching the SQL between the two. And that's just a lot of labor. And also, I think the most important thing is we're breaking the data lakehouse promise,
Mhm.
right? We're not keeping a single source of truth of data on the data lakehouse anymore, right? We're copying data out of it. So we lose all of the data governance benefits. And yeah, that's originally promised by the data lakehouse architecture, right?
Mhm.
So why is the case, right? So why are queries running slow? So first on the bigger picture, right? On the highest level, query engines used for data lakehouse today are not really built for this kind of workloads, right? I mean, storage, data lakehouse, table formats, they're built for data warehouse like workloads, but the query engines that people are using today are not. So some of them are optimized for long running batch workloads, not really low latency, high concurrency queries. They're optimized for stability for jobs that runs for hours or even days. Or they're built for complete different purposes, right? Some of them are built to connect to all possible data sources, data lakes, TP databases, or key value databases directly query, but not optimized for performance for one or for a few data lake houses, right? And this is a problem. And also on the technical side, right? Fetching data, metadata can more easily become the bottleneck, right? So for data lake house queries. So first you have to consider the cost of the network IO, right, itself. So fetching, terabytes of data from an external storage takes a lot of network IO. And for any query engine that is able to do joins and high cardinality aggregation, it has a server service, right? So it's able to shuffle data around between the nodes, right, to redistribute the data at query execution. And this actually slowed down that process as well, right? And second, you have to consider the slow and unpredictable performance of data lake storage systems, like meta stores and data store, right? For example, like AWS S3, the latency can be words of 100 milliseconds, and that's really not that fast enough for data warehouse like workflows. And also data files and metadata files can be unoptimized for query performance as well, right? If you have, too small of the data files, the data scan is extremely slow and expensive. And also, for like metadata, if you don't have enough metadata files, query engines cannot really parallel read, right? So this is very different from data warehouse, a proprietary data warehouse setup as well.
So give me a vague idea about the performance comparison that you're going to get here. When you say things are much slower, how much slower are we talking about?
Depends on what we're talking about.
Yeah,
so like
sure.
storage, for storage device, that can easily be 10 to multiple tens of times of difference, right? But with the technology available today, I mean, also the difference depends on the query profile, right? Is if it's CPU intensive or is IO intensive, right? The more CPU intensive, the closer the difference. The more the IO, because just a different hardware that we're running, especially for IO, right? But with the right optimizations, it's not really that many. I'm gonna show in very, very shortly. The difference can be very minimal, and I'm gonna show some benchmarks as well for this.
Sure.
Okay. So how do we accelerate data lakehouse queries? So first, a hierarchical caching framework is necessary, right? Both for metadata and data. So you want to cache the data in your local instances, not persist, but cache the data there to accelerate your queries. So what this does is first, it overcomes unstable performance of data lakehouse systems, storage devices, right? And also it saves IO costs of actually, from fetching the data from external storage, because you have the option of reading, the cache data in your local instance, right? And second, you want to always find an MPP query engine or query engine with the MPP architecture, massively parallel processing with in-memory data shuffling, right? So when it shuffles data, it doesn't touch disk, right? So it runs faster for low latency workloads. And also, to be better, you want the entire query process, query execution process to be run entirely in memory as well, right? And also you want to find a query engine that's written in the lower level language to fully utilize SIMD instruction sets, right? SIMD basically says we process a batch of data with one CPU instruction.
Single instruction, multiple data, is that right?
Yes, exactly. Single instruction, multiple data. And everything OLAP. OLAP is all about batch, right? Just think of, account sum, or a sum aggregated query, that operation. Everything is a batch. The more batch we do, the better, right? And also for hear a lot about, vectorization, right? That's processing everything in batch, in memory as well. And columnar storage, grouping everything in batch. So with the right tools, getting data warehouse performance on the data lake house it's not only possible, it's actually quite easy to do, right? And here I want to show some numbers really fast. So here first, let's introduce a query engine. It's called StarRocks. The reason why we're introducing StarRocks is because StarRocks can be both. It can either be a proprietary data warehouse or it can be a query engine in the data lakehouse architecture, right? The only difference between the two is that the storage device, the storage engine is using, right? The format that the files are stored. So with a data warehouse solution, files are stored in StarRocks' own file format, managed by StarRocks tables. And on open data lakes, files are stored in open formats, such as Parquet files or RC files, and managed by table formats, such as Delta Lake, Apache Iceberg, and Apache Hudi, right? And now let's see the differences. So first, before we compare, we need to get some sort of a baseline. of the performance, right? StarRocks is incredibly fast as a data warehouse by itself, right? So it's just some baseline performance, and this is a SSB 100 gigabytes data benchmark test, right? So everything you see with a flat on the right-hand side is the denormalized test that's created by Lakehouse, right? So we only do the on-the-fly aggregation and not on-the-fly joins, right? And everything with the multi-table. StarRocks is with the on-the-fly joins as well, right? So let's see the comparison. So StarRocks single table performance is actually faster than Lakehouse single table performance. It's so much faster than Apache Druid single table performance. And StarRocks multi-table performance is actually faster than Druid single table performance. So basically doing on-the-fly join for free and even faster performance, right? So StarRocks is an extremely fast data warehouse. So how does it compare with itself, right? The data warehouse and data lakehouse solution, so TBCDS, is this complex query, right? Like those ad hoc queries with a lot of joins and a lot of high cardinality aggregations, right? With the data warehouse, the data is persisted actually on local disk to maximize performance. Hot query, same exact hardware, and the data warehouse solution is only 12% faster. We need to think about this, right? 12% of the performance difference. So what advantage we're getting? So we're basically able to unify all of our workloads on a single source of truth data. You're able to manage all of the data in a single copy. That saves storage, flexibility, and all of the Lakehouse benefits only for 12% of the performance difference.
I was going to say that's the trade-off now using StarRocks here is you don't have to keep moving this data around. You are using with your single source of truth, you give up 12%.
Yes, exactly. Let's go. And also let's compare StarRocks, a query engine that's purposely built, for a data warehouse like workloads to another query engine, that's not really built for this kind of workload. Let's compare StarRocks and Trino. StarRocks is actually 4.6 times faster than Trino, even with Trino on 4.3.4, version 4.3.4, and that's on JDK 21. It's supposed to, get a huge boost from the, the JDK, the new JDK version, right? Claim to do auto SIMD, a lot more SIMD optimization for Java, but still, we still have that huge performance lead over Trino on TPCDS 1 terabyte. Okay, so now let's take a look at how this unwrap in actual production systems, right? So this is Trip.com. Trip.com is a huge global travel company, right? And ArtNova is their kind of unified reporting platform, and everything goes through ArtNova. Every report goes through ArtNova. And they were on a classic, I use Trino, but Trino is not fast enough. I need a data warehouse to accelerate kind of use case, right? And actually before the data warehouse they were using is StarRocks as a data warehouse, right? So they were ingesting data into StarRocks to accelerate their overall query performance. So that does solve the query performance challenges, but it comes with, other costs. So first, data freshness. Data freshness lacked a little, despite, StarRocks can do, as a data warehouse can do real-time analytics, right, with like 10-second data freshness. Overall, it still lack data freshness and affects the flexibility of timelessness of their queries and insights get from it, right? And also, they have to consider the complexity of the data pipeline, right? Due to the additional ingestion task and additional table schema design they had to do with the whole new data warehouse, right? And also they had problem with data governance. They're basically duplicating their data from their data lake to their proprietary data warehouse, right? So data governance becomes a much bigger challenge than they thought. So they made a change. What they did is they ditched Trino, and they started using StarRocks as the unified query engine to handle all of the workloads, right? So the immediate benefit for that is a streamlined architecture with one less system to worry about, right? And immediately out of box, they saw a 7.4 times raw performance gain on the same data that stores on Hive, right? And also, StarRocks has this materialized view feature, right? So it's able to create a materialized view, and it's able to automatically route all of the queries to the most appropriate materialized view automatically. So you don't really need to change your SQL script, right? And this pairs great with StarRocks' own on-the-fly join and aggregation, just on-the-fly computation performance ability, because they could build materialized views on the fly and without worrying about changing the SQL script. And actually, in the end, they solve all of their slow queries with only 4 materialized views constructed, right? And full code rewrite capability ensure there is no actual work for the data users need to do, right? So overall, they saw a 10 times plus performance improvements when compared to Trino, right? And most importantly, all of the slow queries are gone.
Right.
Okay.
And that's going to be very important considering their business model.
Yes. Nobody likes slow query. And
No,
this is
well,
a huge problem for...
There is no business model that encourages slow queries, but in terms of them having to, the sorts of responses that they have to get, the analytics, the pace at which they have to do analytics, that's huge.
Yeah, exactly. I think variation in query latency sometimes it's always more harmful than overall performance.
Yeah.
Right? Nobody wants, query that runs for 3 seconds and another one runs for 20 seconds. And this is a huge problem for data lakes as well. Because like if you're using HDFS system, especially, it's locally deployed, the performance is not really that guaranteed. So you definitely need some, some special technology to take care of that pain point, that issue. Right?
Yeah.
And StarRocks is great, right? The core is really good. It helps you do a lot of things, to help you digital data warehouse. But it's relatively easier to maintain when compared to other open source solutions, right? It only has 2 kinds of processes. It doesn't have any external dependencies, but it still comes with cost, to maintain your own StarRocks cluster, right? So first you have to consider the cost of actually maintaining the full infrastructure, right? On-prem or on the cloud comes with this cost, right? And also StarRocks has rudimentary security and access control features, but probably not enough for you to run an enterprise level workload, right? Like for example, like for access control, it has a full RBAC, a role-based access control system, right? But nothing actually more than that, right? The architecture is there, but not with enterprise level features. And also you have to consider the graphical interface. A lot of people prefer that, but StarRocks doesn't really come with one. So everything you have to manage through SQL scripts. And also ecosystem integrations. StarRocks has amazing open source ecosystem integration, but for commercial certified ones, StarRocks doesn't really have that many or doesn't have any. So here, want to address this challenge. I think I should go to the next slide. Okay, so here, I want to announce the public preview of CelerData Cloud Serverless, which is a fully managed service query engine that is based on StarRocks, right, with enterprise features that's available today in public preview. And what it does, it has basically 3 layers. So first, the cloud service layer and the compute processing layer, right? So the cloud service layer is all of the management, that's hidden below it, right? All of the UI interfaces and your compute processing, and you can bring your own data lake to this system, right? You can bring your own Hive tables, Apache Iceberg tables, and connect that to CelerData Cloud Serverless and start querying them right away, right? Any data lake with support. And it is fully managed, so there's 0 infrastructure you need to actually manage. And also it has a pay-as-you-go cost structure, just like AWS, right? So you get charged by the second. And also you get security, advanced security features such as e-movement encryption and access control, advanced access control features such as like column and row level masking, right? Access control. And also you're able to perform everything on a graphical interface, right? With advanced monitoring tools and SQL profiling tools and more. I'm going to show in the demo in a bit, right? And also it has enterprise level BI connectors, including Power BI, right? Next slide. And here's one feature I want to show before we actually start the demo. So is how CelerData Cloud Serverless is able to handle physical isolation of workloads, right? If you have a heterogeneous workload, and this is really what you want, right? You don't want all of your workloads mixed in a few VMs on the cloud, right? So with CelerData Cloud Serverless, you can create compute warehouses, right? So they're physically isolated compute warehouses for different workloads. So you're able to manage your CPU, your memory, your disk, and network I/O completely separately, right? And you can scale each workload independently as well, right? So what this does is help you to protect your business workloads, ensure that it always has the appropriate number of resources that need to run smoothly. Right. So some scenario can be, a separation of ingestion and compute, data ingestion into CelerData Cloud and compute, right? A separation of materialized view and materialized view refresh and compute. And also separation of compute and compute. You have your BI workloads as one warehouse and your ad hoc queries as another warehouse, right? So here, that's all I have for the slides for now. And
but we have a
let's
demo.
do the demo.
Yeah, don't spoil the surprise completely. But what's in the demo? Are you going to go are you going to look through and show people how Cloud Serverless works?
Yes.
Excellent. Let's have a look at the demo.
Okay. So now we are in the CelerData Cloud Serverless console. And what we're going to do now is we're going to first take a tour of the CelerData Cloud Serverless platform and see all of the features and functionalities. And then we will connect CelerData Cloud Serverless to an external data lake system that I have prepared. And we're going to issue some queries against that external data lake system. Right. And first, let's take a look at the first functionality, warehouse. Warehouse, as we mentioned before, they're compute resources of CelerData Cloud Service, right? Because there's no infrastructure actually for you to manage. They all come in t-shirt sizes, right? So for this, it's the default warehouse that comes with every single CelerData Cloud Service deployment, and it's X small, right? It's smallest possible warehouse. And CelerData Cloud Service has an multi-warehouse architecture, right? You can spawn physically isolated warehouses within, the same cluster, right? And isolate your workloads, right? You can protect your business critical workloads and make sure that it always has the appropriate number of resources for it to run properly, right? And now we add a warehouse for today's demo. We're gonna do warehouse size large, and we're gonna want to turn on auto suspend for this, right? So what it does is that after a certain number of minutes that the warehouse is idle, it's going to suspend that warehouse, right? So keep the charge to 0. We like that, and we just keep it default 30 minutes, right? It's gonna take a little while to finish, and in the meantime, let's go take a look at other features, right? So first, users and roles. CelerData Cloud Serverless features a full RBAC system, right? A role-based access control system, which means that for each user, you can grant not only privileges, you can grant roles to that user, right? And manage everything by roles. And not only that, and for all of the roles, you can not only grant privileges, you can also grant roles to roles. So roles can inherit each other, right? So make it so much easier to manage. And also all of the privilege user role related maintenance can all be done through this UI, right? So you don't have to maintenance, SQL scripts and write SQL scripts. Nobody likes that, right? And with usage and billing, so for usage, this is a complete pay-as-you-go structure, right? So you get charged by the second, and it features a organization account architecture, right? So within the organization, if you want multiple physically isolated CelerData Cloud Serverless environments, And this is a way to go, right? You can create multiple accounts, and for each account, you can see that as a physically separated enterprise StarRocks cluster on the cloud, right? And you can have the physically isolated environment, but also to get billed and manage all of your bills through your root account, which is the first account that you have created, right? And this is that. And then we're going to connect CelerData Cloud Serverless to the external data lake system that I have prepared, right? And we're going to use the external catalog feature to do that, right? There are two types of catalog within CelerData Cloud Serverless. One is internal catalog, and that is the data and table that is managed by CelerData. And you have the external catalog, right? We're going to use to connect to external data sources, meta stores, and data, right? And let's do that. And my data is in S3. Let's go, and let's name that just demo. And the bucket, the S3 bucket, is in US West 2, and we're using Hive table format. It's in Hive table format, and it's managed by AWS Glue Metastore, right? And the region is the same region as well. Next, authentication methods. So there are two ways provided to authenticate, right? So first way is through access key and secret key, and the second way is through IAM roles, right? We're going to use IAM roles for this because it's more secure, right? So for this, you would need to create a role in your AWS account wherever the data lake system is, and attach policies to that role, right? Appropriate policies, privileges. And then CelerData Cloud Server is going to assume that role to gain the same privilege, right? I have done all of that already, but it's pretty straightforward. It should not take more than 10 minutes. So it's all here. Let's just do it right now and create. And now we have an external catalog, a Hive catalog called demo, right? With no description. And let's go to our SQL editor, and we can see that instead of the internal default catalog, we now have a Hive external catalog called demo, right? And we can see all of the databases that are in here. We have a lot of databases in here, and let's use this one. The TBCDS 1 terabyte data set in Parquet files, right? And this data set is just a standard TBCDS 1 terabyte. It's not really optimized. So let's show all of the tables that are in this data set. TBCDS is a multi-table schema, right? So it has a bunch of tables. And we're going to run a pretty complex query against this schema, right? Let's first run the query, and we're going to explain what we're doing here, right? So this query analyzes the spending behavior of customers who have purchased this category of items, in May 2000, right? And segment their future revenue, over the next 3 months to get a better understanding of that group of user, right? And to do this, first we need to get all of the customers, right? We read a bunch of tables, join them on the fly, right? And some predicates, we want sports and fitness, and we want the time, right? And then from the customers we just got, we compute their revenues, for the next 3 months, right? And to do that, we need to read a whole bunch of other tables and join all of the 5 tables together on the fly again, right? To compute the revenues for the next 3 months. And we're going to segment them and return the result, right? Results should be ready by now. Yes, it is. The execution time is 16 seconds. And we can see that we have a bunch of segments and number of customers in each segment, and the base value, which is the lower bound of the revenue, that segment generates, right? 16 seconds is pretty good for this case, right? First, we don't really have that big of a cluster. And second, this is completely a code run, right? So both of the metastore, the metadata cache and the data cache are actually cold, completely cold, right? We're reading everything off of S3 and Glue. right? And to see that, what we do is we can see the query profile here on the fly, right? And so this is the query we just ran, and this is the SQL, right? And we can see the query profile right here in the beautiful DAG, diagram, right? We can see that all of the all of the most expensive operations are all scan nodes on the S3, right? So most of the time are spent, scanning the data instead of actually computing them, right? And this is very useful, right? It's very useful for you to optimize your query as well as your data, right? You can see whether the data is skewed, right? And whether the query written is optimized, right? And see really how it's run on the fly, right? And this is all I have. Let's go back to the slides. Okay, so now we have seen the demo, and this is actually all I have for today's presentation. So yeah, go pipeline free today. Like, get rid of your data warehouse and get rid of all of the crazy ingestion pipelines, right? Actually go pipeline free.
Yeah,
and
I
CelerData
normally
Cloud.
around this time, Sida, I ask people what should they do next, and you've got there before me on this one.
Thank you. And yeah, so to try CelerData Cloud Serverless is actually we're running a $500 free credit now. You can register today and claim your $500 free credit, free usage credit on CelerData Cloud Serverless, right? That's gonna keep you actually going for a pretty long time in CelerData Cloud Serverless. You can try CelerData Cloud Serverless at serverless.celerdata.com. Or if you're not ready for that, if you want to learn more about StarRocks, you can join the StarRocks community Slack channel. Right? We have really active Slack channel on Slack community. You can join them and join the discussion. Talk about data lakehouse and queries, running queries against data lakehouses, right? And go sign up. And do we have any questions?
We got no more questions sitting around for you, Sida. But thanks very much for that. We've got some. We also have some links as well for anyone who wants to chase up any more information about this. You've packed a lot in. I've got a feeling, Sida, there's going to be plenty of people that are going to be scrolling back to the demo and having a look again, but that was great. You really got into it, and so you can really find out how this works, because that's what counts, isn't it? Sida, thank you very much.
Thank you so much, Tim. Thank you for having me.
You're welcome. Thanks to everyone who was watching today. I hope you got what you wanted. If this is what you came for, I think you're going to be pretty satisfied with the amount of detail that Sida's been able to give you. Let us know if you want us to cover it some more, or this topic anymore. If you ask us, then we'll do it for you. Thank you to everyone at the register behind the seats who helped put this on. But now our time is up, so it just remains for me to say, Tim Phillips, goodbye. See you soon.